All right. Welcome back to another episode of Diaries. Today we're going to be creating a simple delegated token. What is a simple delegated token? Well, a simple delegated token is basically a token in which you entrust someone to run certain functions in your contract. The difference with today is that I'm not going to be doing this step by step live. I already done this simple delegated token, ran into a few problems messing with the RAM, but we're going to go ahead and get into it and I'll explain the process. So basically we're going to copy the same thing that we have from simple RAM token and we're going to paste that, but we're going to make a few changes. Number one, change the simple delegated token. Number two, this is when we get into the meat of the function. You will want a global a global storage map called delegates, right? And the storage map in Phantasma mean that the storage is going to persist. So it's not like local or anything that's in here, meaning that once I run this, the storage is gone once it's done running. Storage with storage map is going to persist. Global as well. What we want to do for this is that we want to have possibly a multitude of users that can make changes to certain functions, right? So in order to do that, we'll create our storage map, have an address, and we'll have a number. The number I can explain in my mind is I might want a user to have certain roles. So address might have certain roles. Let's say if the number is 1, that means they can update a certain function. If it's 0, kind of like admin, admin or you're just a basic user, right? Something similar to that I was going for. All right. Once you get the delegate storage map, next thing you will do, you don't have to worry about any of these other functions. You'll need a function to add a delegate. So you will want to add a delegate, runtime.expect. You'll want the owner. Only person that can add a delegate is the owner of this contract. You don't want anybody to nilly-willy add a delegate, and you do not want a delegate to have the option to add more delegates. You could add a some type of condition in here to say if a delegate has, let's say the number could be 5, which means that they're admin or they're part of the owner, then yes, they can add another delegate. However, only the owner can add a delegate right now. You don't need this string delegate. I was just testing something out, so I'm going to remove this. So we're going to just remove that. It's going to say users are a delegate. Then in order to set a delegate for the storage map, we're going to do delegate 1, set it, just a dot set. Same thing with update durability. Once we set that delegate, then we'll want to have the only function we're going to worry about right now is our update durability. So once we set our delegate, all right, now let's check to see who can update this durability. We're going to read our NFT struct to see who the owner of this NFT ID is. Once we find that owner, we're going to see if the owner, we're going to set a variable called has access. And what has access would do is if you are an owner of the NFT or if you are a delegate, you can change this, you can change the update durability, or you can update the durability, so to speak. So first thing we will do is if you're an NFT owner, owner, if that's true, you have access to that, then you can go ahead and change this. Next, since Phantasma basically does not have if else statements, you'll have to create your own. So this one is going to say if the person who's running this function or who address is used as a parameter in this function, if they're a part of the delegates and they are a witness, right, meaning they're going to sign this transaction, then has access is true, then they have access as well. And for our runtime inspect, we're going to say, okay, if you have access, then you can update the durability. If you don't have access, you can't. One thing I will add on here is we're going to just say we're going to add is delegate, and I believe this might cause an issue. We're going to say delegate address. Actually, I would like to get delegate. I would like to get everything from here. The problem is I don't think that I'm able to just for loop through this, so I don't want to waste any time trying to for loop. I know who a delegate is for one. Or yeah, I'm gonna check is delegate. I'll just do a is delegate check. I was gonna say return delegate dot has delegate. Okay. Return delegate dot has delegate. So that should return true or false. Okay. Now let me change directory and go to our delegate contract. So simple delegate token. Now I'm gonna run this tune SDT. Invalid method definition is delegate. Public is delegate. Oh. I don't think I need this one. Yeah, I do. Bool. Okay. All right. Let's minimize that. Go up here. Phantasma Hub. Okay, local. No. I need to manage this contract. SDT. Okay. Open my wallet really quick. Connect. Deploy token. All right. Should be no issues. So I got my trusty Docker. All right, let's go to contract interaction. I could have did that a different way. SDT. Let's check is delegate first. Actually, I shouldn't have a delegate on this yet, should I? No, I shouldn't because I didn't deploy this yet. Okay. Let me add a delegate. Let me exit out this contract real quick. Grab me this, copy this address. Put this right here. Go back to my node 1, connect back. All right, send raw transaction. Let's add this delegate. All right. And I want to check if is delegate, if it's actually in there. So, and I didn't even mint yet, just to be honest. I'll still have to mint. So let's send raw transaction on this one. Is delegate, invoke transaction. So now we know this person is a delegate. We could actually have another function on there called remove delegate. I'll update. I'll put that in the contract right now. And it'll be the same thing. Runtime.witness is on there. All right, let's just put this in here. Basically, copy and paste this. Runtime owner, delegate, expect. Remove. Let me make sure. I believe it's called remove. What was I looking for again? Something with remove map. You know, the problem with doing the videos is that, oh, it is dot remove. Okay. So let's see, dot remove. And I'll have to change this right here. Expect delegates dot has delegate. All right. There we go. Okay. There we go. I'll upload this though, but I don't need to test this right now. That's just for purpose sakes. All right. Now let me mint from this one to this one. We're gonna mint one. No. Let's put a 0 series ID. I don't have an SDT token in here. Send transaction. Okay. All right. That should work. Now this is where we'll have an issue at. I explained it on my Twitter, but I'll show you right now. If I try to mint this again, the problem is I believe there's not enough space on the contract to provide another mint, and I gotta look into that because this is only happening with when I have RAM token, when I have RAM on my NFT. On the old NFT, when I didn't have RAM, there might be a cap limit. I don't know that limit depending on the size of the picture or so, the size of the ROM, but I don't think I could mint this again because of RAM in specific. Yeah, you see error calling SDT, and when we go here, we're going to see not enough storage space available. Requires 779, only have 211 at write data. So that's something that I'll have to look into. And once I find that out, I'll make a video on that. But in the meantime, we're gonna read the RAM. We could do this at least for what we have right now. Read RAM. I don't have the NFT ID number. We'll go to blockchain interactions. No. Yes. All right, blockchain interactions. We're going to say get account NFTs by contract. That should be fine. All right, let's see what happens. Let's get this. It's taking an awfully long time there. Thank you. All right. Then we're going to head back up here. Going to get this NFT number, invoke transaction, so we can see everything, you know, just so you can verify that everything is working fine. All right. I'm going to update the durability. From the original contract, as you can see right here, not from the original contract, but from this owner. This is the owner of the contract. We're going to do that. Then we're going to do it from the let's just update it to 4. Then we're going to update it from the delegate, right? All right, and read RAM 4. Now we're going to disconnect, and just so you can see, disconnect, exit, node 1. So now that we're on node 1, we're going to connect. And I believe my node 1 is a delegate. Let me just double check. Is delegate true? All right, we're going to update durability. Put in this P2K6. I believe that's right. Yeah. NFT ID. Oh, I gotta grab that back because I don't know what that one was. Okay. And we're gonna update this to about, let's give it 1. Actually, I don't even want a 1. I want a 0. There is no durability on this since the RAM is broken. When I try to mint another one, I'm making sure the durability is broken. Everything's broken right now. So I'm just gonna break this as well. Break the weapon. You know, break the weapon. Let's go ahead and call that. If I get an issue with this, I'm going to lose my mind. And I didn't. Of course I didn't. All right, invoke transaction. Durability 0. Perfect. Now this weapon is broken. If that's what you wanted on your game. The next thing we would do, this is the main point of this. To actually putting in a what is their name? A delegate, right? When you're on the back end, you're not going to want to call or have the user update whatever their RAM is 24/7, right? You might want to take that action off of them so they can entrust another user, or you would entrust someone else to update this RAM, just the RAM. So this would be the back end. And I already updated this to the code too as well. So you'll call this, say whenever a user might save the game, or they might log out, however you want to do it. Say you have all of this in your database. Say you have this durability. I kind of want to show you so that way I'm a visual person. Let's say you have this durability in your database, and this is saved in your database. When the not to the blockchain, but to your database when a user swing their weapons or something like that, right? When this is saved to your database, and the user logs out, you might want to write that to the blockchain, and you do not want to require the user sign the transaction for it to write to the blockchain. You want to delegate that for someone else to do. That's why we'll have this blockchain interaction right here. This right here, you can have the WIF and the address. You don't want the user WIF. The user is not going to give you their WIF because you'll have access to everything in their wallet. They're not going to give you that. That's why you want to use a delegate. So that way you can have your own, wallet, your own WIF. This is basically access to everything on their wallet if you do not know the WIF is. So you do not want to have a user give you their WIF. So you have your own WIF and you just use that to delegate to sign certain transactions on behalf of the user. Now, keep in mind, when you sign a certain transaction on behalf of the user, you will use your own kcal. You use your own kcal. You could require the user deposit a certain amount of kcal, but you would use your own kcal for that. Just keep that in mind. So let's just run this. Say if we want to update durability. Let's get this out the way. Send trans. Let's see. SDT. No. There we go. Let me make sure. P2K6. All right, this is the node address. This is the WIF. This is incorrect. All right, this is the NFT ID. We're going to update that durability to 6. All right, so let's look at this. All right. I'm not seeing transaction. Get token data. I don't know if I did. Let me check. I don't think I sent that transaction, but we'll check anyway. No, I didn't. Okay. Guess I didn't save it yet. All right. Let's make sure this is okay. All right. Looked like it went through. There's nothing on our Docker to say there was an issue. Now let me go back here and let me check. And the durability is 6, as you can now see. So this is what you would need to do to take off pressure off the user so they don't have to sign. Could be ease of use. That's what they usually call it, ease of use, so the user don't have to worry about signing everything every single time they do something. I mean, I guess after this, you're fine, but just keep in mind, I'm not sure what it is with this RAM. This has been bothering me, so I got at least a good 30 seconds. I'll make this a 20-minute video. I don't know what it is with this RAM and trying to make a new one, and I won't even be able to do this. So it don't matter. I don't know what it is. I don't know what this means right here at the moment. And I've been looking at this for a good minute, but we're going to figure this out. Once I figure this out, I'm going to mint a lot of NFTs with RAM, and I'm going to try some crazy stuff. But until then, thank you for tuning in to another episode of Dev Diaries. You now have a way to delegate someone to sign transactions to update the RAM, and have a blessed day.